Boeing's updated F/A-XX concept reveals a highly evolved vision for the U.S. Navy's future carrier-based tactical aviation. Its visual and structural resemblance to the Air Force's NGAD selected F-47 platform is not coincidental. It signals a shift toward unified design philosophy across services, intended to maximize both operational capability and industrial efficiency. This is a major departure from previous generations of tactical aircraft development, which often saw the Navy and Air Force pursue distinct designs, tailored for their own unique operational environments. The core of this strategy appears to be modularity. By building around a flexible architecture that can be adjusted for carrier versus land-based roles, Boeing reduces the need for entirely separate aircraft families. Instead of starting from zero, the Navy can benefit from the existing design and development work invested in the F-47. The result is a lower barrier to production, faster prototyping, more streamlined sustainment pathways, and more affordable long-term logistics. Boeing's deep investment in digital engineering, rapid prototyping, and advanced manufacturing systems at its defense facilities, including in Missouri and California, supports the feasibility of this approach. A deeper look at the F/A-XX concept shows several performance priorities. Stealth remains a top concern, but the Navy's concept balances this with carrier-based requirements like low-speed stability, reinforced airframes, and aerodynamic control during catapult launches and arrested landings. The aircraft's shape, featuring a wide fuselage, flush inlets, and sharply angled features, suggests a strong focus on minimizing radar cross-section. The use of potentially active materials or specialized coatings may be incorporated as well, allowing the airframe to adapt to different radar bands or frequencies in a way that enhances survivability in contested airspace. Beyond stealth, range and payload capacity have become defining features of sixth-generation aircraft. The Navy has made clear in multiple budget requests and strategic documents that it requires fighters capable of operating well beyond current strike envelopes. This is largely driven by the need to maintain standoff capability as carrier strike groups face longer-range threats. Traditional legacy systems simply cannot reach deep enough into high-threat areas without putting assets at significant risk. The F/A-XX is expected to address this with advanced propulsion, likely incorporating variable cycle engines that can shift between high-thrust and fuel-saving modes. These engines, under development in multiple U.S. labs, are designed to dramatically extend unrefueled combat radius while providing the acceleration needed for air-to-air engagements and rapid mission changes. In terms of mission flexibility, the Navy's future air dominance fighter is not just a replacement for the F/A-18, but a central node in a new operational construct. Rather than being the sole sensor or shooter in a mission package, the F/A-XX is envisioned as a highly networked battle manager, coordinating the actions of manned and unmanned systems across vast distances. It will likely include onboard artificial intelligence capable of managing data streams, filtering battlefield information in real time, and autonomously prioritizing threats and targets. This capability is essential as the Navy continues to develop its future air wing around the concept of distributed operations, where information superiority is as critical as kinetic power. Another major leap will come in electronic warfare and survivability systems. The Navy anticipates a future environment dominated by advanced jamming, cyberattacks, and electronic deception. Aircraft like the F/A-XX will need hardened communications, highly secure data links, and onboard tools to detect and defeat electronic threats. Integration with the Navy's broader electromagnetic spectrum architecture will also allow the aircraft to serve in both offensive and defensive electronic warfare roles. This is in line with the shift away from single-mission platforms toward aircraft that can conduct simultaneous roles within contested domains. Carrier integration remains a unique challenge for any naval aircraft. The physical stress of arrested landings and catapult launches imposes specific engineering constraints that land-based fighters do not face. Boeing's approach appears to incorporate robust structural enhancements into the same basic design as the F-47, implying a shared airframe that is engineered from the start to accommodate those stresses. This is a major advantage over past efforts to modify Air Force jets for Navy use, an approach that often introduced weight and reliability problems. Instead, the F/A-XX seems to be born from a dual-service mindset, where the Navy's requirements are baked into the architecture from day one. While funding for the Navy's F/A-XX has been delayed relative to the Air Force's NGAD, this appears to be a temporary adjustment rather than a strategic downgrade. In fact, the Department of Defense's 2025 budget documents reaffirm the critical need to field a next-generation carrier-based fighter before the late 2030s. By aligning its development cycle more closely with that of the Air Force's NGAD, the Navy may benefit from lessons learned, technical breakthroughs, and shared supplier networks, ultimately accelerating its own fielding timeline. Boeing's ongoing work on both manned and unmanned platforms reinforces its unique position in this competition. The company has already developed and flown multiple large-scale, next-generation demonstrators, including autonomous systems intended for naval operations. This experience informs its F/A-XX design not just in terms of hardware, but also in terms of system integration. The aircraft is expected to operate seamlessly alongside autonomous wingmen, potentially controlling them directly during combat missions. These collaborative combat aircraft, CCAs, will extend the F/A-X's reach, allowing it to engage targets across multiple domains without exposing itself to unnecessary risk. One of the most significant aspects of Boeing's strategy is its embrace of open mission systems. The F/A-XX will almost certainly be built around a modular, software-defined architecture that allows for rapid integration of new capabilities, whether they involve sensors, weapons, communications, or AI. This stands in contrast to legacy aircraft, which often required extensive and time-consuming upgrades to accommodate even minor changes. By designing for rapid software iteration and hardware modularity, Boeing is enabling the F/A-XX to stay ahead of the evolving threat landscape over decades of service life. Even as the Air Force moves ahead with full-rate development and early production of its NGAD aircraft, the Navy's own progress on the F/A-XX is increasingly aligned. Boeing's unified design concept ensures that technological advancements made in one program can directly benefit the other, offering a high return on investment for both services. This includes radar, sensors, propulsion, electronic warfare systems, and autonomous flight controls, all of which are being developed in a common industrial ecosystem. If this alignment holds, the result will be a more agile, interoperable U.S. tactical aviation force that can adapt rapidly to new global security challenges. Boeing's F/A-XX concept represents not just a leap in individual aircraft capability, but a restructuring of how future air power is conceived, built, and deployed across multiple domains and services.